Good day. We are carrying on with your more Ksp to solubility notes. We've done 1 to 3, and in this video we'll do number 4 to 6. So, like question 3, we're after a solubility given a Ksp. So reading the question is really important. We're really looking for the value of x. We see this is a very small Ksp, so that gives us a clue that this is not a very soluble material. Well, when we first calculate it, it's going to come out in moles per liter, and then we're going to do a final conversion to make it grams per liter and grams per 100 mils. So we're going to take you through those steps. But our first job is to get the solubility in moles per liter. So we write out our equilibrium. We have our x and 2x, and by now, hopefully you're getting used to this, when you have this 1 to 2 ratio, it always comes out as 4x cubed. Now we're told that 4x cubed equals 5.0 times 10 to the minus 26. So what we have to do is first divide this by 4 and then take the cube root. When we take the cube root, we now have our solubility in moles per liter, so we've answered the first question there. Now we have to take our moles per liter, and we got to convert the moles to grams, and we have to convert that 100 mils to liters. Oh, sorry, liters to 100 mils per 100 mils. So that's what we're going to do. So now we have it in grams per liter. All we did was the usual thing from Chemistry 11, multiply by molar mass, and we get our answer in grams per liter. Now we need you to visualize this. Think of the difference between 1 liter or 1,000 milliliters and 100 milliliters. The bottom line is, if we only have 100 milliliters, we only have 1/10 the volume to dissolve this stuff in. So the amount we can dissolve will be 1/10. And so we take this answer, we divide it by 10, and that tells us it's 3.5 times 10 to the minus 8 grams per 100 milliliter. Less volume, less mass that can dissolve, and it's a factor of 10 that we're dividing by. All right, now you might say, hey, what's going on here? If this was totally soluble, it'd be quite simple, but this is not a very soluble beast. It says it's saturated, and so in other words, we're going to find the solubility, and we're going to relate that to what these things are actually telling us. So when this dissociates, we get the 2x and the x. So first thing is we're going to solve for x. Once we have our solubility, then we can answer the question. And the chromate, the concentration of it, will equal the solubility, and the concentration of silver ions will be twice that value, because we have the 2 here and 2x. So we're going to have our usual 4x cubed thing. And here we go, boom, boom, boom. 4x cubed equals 1.9 times 10 to the minus 12. We divide by 4, we take the cube root, and we end up with 7.8 times 10 to the minus 5. So that would be the solubility. We're going to see that equals the chromate, and we have to double it to get the silver ion concentration. And that's it. So if you're organized like this, these questions are very straightforward. But you have to read questions carefully, and you have to be organized. One more example coming up. And for some reason I put those in bold. You don't have to recopy them. Now we want to know which is the most soluble out of these 3 materials, and that means we go to our solubility chart. We look up each of these beasties on our chart of KSPs, and you might say, this is clearly the least soluble. Hey, maybe that's the most soluble. But we can't get directly from KSP when these ratios are going to be different. Here's 1 to 1, here's 1 to 2, and here's 1 to 1. So we're going to actually go through and calculate solubilities very quickly. To get the solubility of this, we're going to take the square root. To get the solubility of HGS, we're going to take the square root, because it's 1 to 1. To get the solubility of this, we're first going to divide by 4, and then we'll take the cube root. So when we do that, we get 7.1 times 10 to the minus 7 big M for HEBr. Seven 7.9 times 10 to the minus 6 big M for FeOH2. And just taking the square root. And we are going for the biggest number out of those. And we see right here, that is the biggest number out of these three in terms of solubility, which is our value of X. So hopefully these examples are giving a bit more clarification than the previous ones, and you're finding your way quite happily with this material. We have some random things coming in here. And of course there's no real point to that. Oh, come back for more fun. Good teamwork.